Welcome everybody to our fourth session of the School Garden Leadership Training Series. We're happy to have you here today for this session, which is titled Here Fishy Fishy, Aquaponics in the Classroom. And my name is Tiffany Torres. I'm the State School Garden Specialist with Florida Agriculture in the Classroom, one of our co-hosts, and I'll be facilitating today. We have some great guest scientists as well as some teachers here with us today who have many years of experience supporting aquaponics systems in schools across Florida, and they're excited to share with you. So thanks for being here, and we'll get started. So one of our goals with the series is to increase networking across the state between educators and school garden leaders. So if you haven't already, please go ahead and introduce yourself by typing your name into the chat box, as well as your organization or school, what county you're in, and whether or not you've tried aquaponics before. You can share a little bit of your story if you'd like. And note that you can also rename yourself and include your pronouns in Zoom by clicking the three dots next to your video box. So before I introduce our guest speakers, I wanted to take a moment to ground us in what this training series is really all about and who the experts are that are here to help you. This webinar series is brought to you by Florida Agriculture in the Classroom and the University of Florida IFAS Extension Family Nutrition Program. And all webinars will be recorded for future viewing, and CEUs are available upon request for those who need professional development. Just a reminder to please mark your calendars for the remaining sessions in our series. So we have two left this spring. The next one is April 6th, which will be on careers in the industry. We'll have a fun panel for you all to see. And you can register for any of these on our Eventbrite page. And you can also look at the previous recordings on our YouTube channel at any time. So this webinar series is designed for Florida school garden leaders of all levels to build gardening confidence, foster collaboration among leaders, and strengthen garden programs for long-term success. And we do this by incorporating three core elements into each of the sessions that we host, which include gardening knowledge, so hands-on technical skills that you might need for your gardening projects, curriculum connections, as well as community engagement strategies that are going to help you build your network as you grow your program. And speaking of community, I also want to remind you that you can continue any conversations that you start here today by joining our Facebook group, which is linked in the chat box and at the end of this presentation. We're hoping to grow a statewide network that can continue to interact with one another. And both Florida Agriculture and in the Classroom and the Family Nutrition Program are here to support you every step of the way. So please reach out directly to us if you need any additional consultation services. And with that, I just want to expand on Florida Agriculture in the Classroom briefly. So we are a statewide nonprofit that is funded through the specialty license plate Ag Tag, which you see here on the left. We provide a variety of educational resources for free on our website, including school garden curriculum, activity newspapers, agricultural themed lessons, and more. We also offer farm to school programming, such as the Agricultural Literacy Day event, virtual farm field trips, workshops and trainings, and school garden consultation services. We also offer grants throughout the year. All of our grants and awards are currently closed right now, but will reopen in the fall for the next school year. And you can see all of our contact information there on the right, so please don't hesitate to reach out to us at any time if we can support you with any of your gardening goals. And our second co-host of this series is the University of Florida Extension Family Nutrition Program, or FNP. FNP provides SNAP education in Florida across 40 counties and has been doing so since 1996. FNP helps limited resource families in Florida access more nutritious food choices on a budget and adopt healthier eating and physical activity habits to reduce the risk of obesity and chronic disease. And so we're happy to have our speakers here with us today. We have Eric Cassiano, who works as the Assistant Extension Scientist with the Tropical Aquaculture Laboratory at UF Extension. We also have Joe Malone, who is a science teacher and director of the Academy of Natural Resources at Island Coast High School in Lee County, and Katrina Bayless, who is a biological scientist with the Division of Aquaculture and has at FDACS and has some amazing resources for us to share. And myself and Becky Sponholz will be facilitating. So just a quick overview before we dive into our presentations. First, we're gonna go into a little information about field trips. I wanna make a quick announcement about that. And then Eric will walk us through aquaculture, recirculating aquaculture systems, and learning more about the nitrogen cycle, how to teach that in schools. And then Joe will show us through a video tour in person that he recorded especially for this webinar, a little tour of their facilities over at Island Coast High School. And he'll also touch on how to involve students, overcoming challenges with school breaks, and more. And then Katrina is going to do a little live demonstration for us of a mini aquaponics system. So you'll get to see a variety of scales of systems during this webinar that you can pick whichever one is appropriate for your school size and community. And Katrina will also touch on grants, curricula, and other resources that FDACS has to support you. And then we'll close out our time with our optional Q&A session. And so a note on Q&A, feel free to put questions into the chat box as we go. We will copy and paste them out and make sure they don't get lost along the way so that we can readdress them at the end. So we won't stop for questions during the presentations, but all presenters will be available at the end for a 30-minute Q&A session. So with that, my quick note on field trips that I want to share is that field trips are, of course, a great way to teach students about aquaculture and aquaponics industry throughout Florida. We are excited to announce that on May 25th, Florida Agriculture in the Classroom will be offering the first of 5 virtual farm field trips. And it just so happens that our first farm is an aquaponics farm that we'll be touring. So this is Trader Hills Farm. They're located in Hilliard, Florida, up in the Northeast. And they are actually the second largest aquaponics farm in the country, is what we've learned. So this is an exciting opportunity that is free for any Florida educators, and you can stream it live to Zoom or YouTube, whether you're in a classroom or students that are engaged in remote learning can participate. And we'll have an interactive Q&A session with the farmers as well. So please mark your calendars for May 25th. We hope to see you there, and you can continue to learn more about Florida aquaponics. And then if you would like to arrange your own field trip, the FDACS Aquaculture Educators Resource page, which we'll go over later, has a wonderful document that is organized by region and has a lot of different facilities that are open to hosting field trips, of course, COVID precautions pending, to schools and communities. So please be sure to check that out. And with that, I'm going to hand it over to Eric, and he's going to talk to us more about aquaponics and aquaculture. Take it away, Eric.
Excellent. So do I just tell you when to advance? Is that how it works?
Yes, that'll work.
You may advance. All right, thanks. So, let's start with a few definitions. Actually, before I start, I have to say I got some of these pictures and ideas from the late, great Leroy Crestwell and Laura Tu. Laura Tu's a Florida Sea Grant agent up in the Panhandle. First of all, some definitions. So aquaculture itself, husbandry of aquatic species. Basically, that means growing aquatic animals in water. That could also mean that's shrimp, fish, but it could also mean plants as well. So aquatic plants grown in water tends to be classified as aquaculture. Hydroponics is a little bit different. It's growing plants in water, but it tends to be these sort of terrestrial plants, tomatoes, lettuce. Oh, Laura's here. Hey, Laura. Sorry. All right. Okay, great. So it's a little different than growing aquatic plants in water, but aquaponics is sort of the marriage of those two things, aquaculture and hydroponics, where you're growing an aquatic animal and sort of a terrestrial plant within this, what's called a recirculating aquaculture system. And I'm going to get to that in a little bit, what that RAS means, that recirculating aquaculture system. Please advance the slide. Okay, a little bit about the organism contribution. Animals create sort of nitrogenous waste and other dissolved nutrients, and plants absorb those dissolved nutrients. And that's the basis of aquaponics. It's a little more complicated than that. We'll get into it at the end. But not only is this whole relationship going on between plants and animals, but you have an additional crop being produced within the same footprint sometimes. And then sometimes also you have a reduced need for some of these additional recirculating aquaculture system components. And we're going to go into detail in that right now. Please advance the slide. Okay, so what you're looking at is a schematic of a recirculating aquaculture system. Now, you don't have to memorize all these components by any means. What you really need to take away here is that this is basically a loop that the water travels in. And as it travels throughout that loop, it's visiting different components. And these components are really designed to, quote unquote, clean the water, recycle the water, reuse the water, however you want to think about it. But the water travels through this loop and it gets clean. And really the point here is that there's zero, or that's the goal, to have zero discharge, or really at best a very minimal amount of discharge. All right, please advance a slide. Okay, now some of these components, the recirculating aquaculture system components, this is really what it looks like. This is actually a picture borrowed from Laura. This is those blue tanks in the background are the culture tanks. And then these tables in the front are the aquaponic tables, but there's also a system of pipes and fittings and all sorts of other valves and bulkheads and things like that. These could also be considered components as well. I'm not going to go into too much detail about those because I really want to focus on the filtration components. But it's also good to know that this is a part of the loop, and it doesn't always look like a circle, but the water is always traveling in this sort of loop, and sometimes it's many different loops. Advance. All right, probably one of the most important, I'll say the second most important one would be the solids removal. So we have about 3 different categories of solids, and the first will be settable. These are the really heavy items that tend to sink out of the water. On the left, you'll see what's called a swirl separator. Now, this is just one of these types of solid removal equipment, and it literally does make a sort of a cyclone flow within a tank, and all that, those big settable stuff finds its way to the center and then down to the bottom, and you're able to expend it out of the system. There's also, a long tank will do the same thing. Anywhere where you're just giving that heavy settable debris time to sink and settle on the bottom. Suspended solids in the middle, you'll see at the top is a biofilter, a bubble bead biofilter. I'm going to talk about that more at the end, but it does act as a mechanical filter to get out some of those suspended solids. And suspended solids are exactly that. You usually can see them with the naked eye, but they're within the water. But they don't ever really sink unless you give them massive amounts of time. At the bottom there in the middle, you see a cartridge filter. It could also be a bag filter. They kind of look the same. Those are probably really the most common mechanical solids removals that you'll see in line within a recirculating aquaculture system. And again, they're just designed to get those suspended solids out of the water. You're going to have a lot of these solids when you deal with aquaponics. Typically, the fish or shrimp or animal species is pretty dirty, but in the addition with that, plants can be kind of messy as well. So on the right is a foam fractionator. I'm not going to go into too much detail about that. It's more for dissolved solids. You don't really see them a lot within the freshwater systems, and a lot of the systems that we're talking about here today are freshwater. They more function within a saltwater system, but they are designed to get some of those dissolved proteins and lipids out of the water. And it sort of works like a glass of milk that you as a kid or your kids would bubble and blow bubbles into your glass of milk. It eventually foam over. And that's really how it works. It sort of collects these dissolved solids into a foam, and then they overflow out of the system. You may advance. Okay. One of the more important recirculating aquaculture system components is, of course, aeration. On the top 3 pictures you see there are mechanical aeration, right? This is provided by a pump. The pump is on the left there, and it's really, we call this a blower, right? It blows air, creates an airflow. That air is provided to tanks through air lines, and then diffused through either a diffuser or an air stone. And I just have a couple of pictures there at the top, in the middle, and the right, where you could see there's tanks are bubbling with air, and then that middle one is an air lift. But this is really just to design to put oxygen into the water, because these fish and shrimp or whatever your animal is going to be, it requires oxygen to be in the water. Degassing, the bottom set, I include these on the same slide because it can really accomplish the same thing as aeration, especially on a smaller scale. Animals, just like you and me, respire and create CO2. That CO2 wants to stay in the water. It's very water soluble. This can be bad for the organism because it really inhibits its ability to take up oxygen. And it also, in high amounts, can drop the pH of the system. It can be a double whammy in essence. So we really have to get rid of these CO2 accumulating within a recirculating system. So I'm not going to go into too much detail about the design of these. Basically, they're buckets or tubes or barrels, or they're very simple to make. They're elevated out of the water and they contain media. If you look at that middle picture, you can see one is full of these bio balls, these big bio balls that creates media. Really what you're doing is you're pumping water to the top and you're letting it drop down through this media, and it creates essentially a small water droplets, creating a lot of surface area for that CO2 to diffuse across and enter out of this water and into the air. If you want to get really fancy with it, if you look over in the far right, one of our farmers has created a really tall one that's about 15 feet tall. The water inlet goes all the way to the top. The water drops. And then if you look carefully at the bottom, he's actually injecting air into the bottom. So as those water droplets drop through that tower, the air is being pumped up through there, essentially creating a countercurrent, which further draws out the CO2. And so that's a very effective way of not only getting rid of CO2, and all of these are effective at it, but also putting oxygen in to the water. So within small systems, this could be your form of aeration, depending on how many animals you have within the system and how much surface area you have across that system. It really works well with some of the smaller ones. Okay, advanced beams. All right, disinfection. I'm not going to go into too much detail about this one, especially the ozone generator on the right. This is well beyond what you guys should be considering. I just want you to know that it does exist. And basically it creates an ORP, an oxygen reduction potential, which really eliminates a lot of bacteria. The one on the left, the ultraviolet sterilization, we made advanced in this, and it uses exactly that. It uses ultraviolet light, which kills bacteria and ciliates as it passes through that black tube. There's an ultraviolet light bulb inside of that black casing. Okay, please advance. All right, biofiltration. This is the most important part of a recirculating aquaculture system. So you have a moving bed reactor on the left. Basically, it looks like a big bowl of spaghetti. You have these beads that are inside of it. That picture down on the inset shows these beads, and that's really where the bacteria grows. When you're growing anything within a recirculating system, you're growing bacteria. This is what you're doing. You are bacteria farming. And why, we'll get to it in the next slide. So you could do this in many different ways. A moving bed reactor is one. If you look on the left and on the right, you have a rotating biological filter as well. These are all in contact with a lot of oxygen, and as well as the water. And that's what lets the bacteria does its job. These are designed to have surface area so that you can grow the most bacteria that you possibly can to accomplish nitrification, which we'll get into in a minute. Now, the middle one, the bubble bead filter here, it's actually a great piece of equipment. On the top of that hourglass is filled with much smaller beads, and it creates this sort of matrix mesh that acts as a mechanical filter. But then, of course, it has the beads in there as well, and so the bacteria are able to grow on the beads. And so you're able to do both biofilter and mechanical filter, and all you have to do is really backwash it. So I highly encourage anyone to look into using these if it fits, because it accomplishes two goals at once. Okay, please advance. Okay, so why are we growing bacteria? You have fish, or that's our animal in this case, right? Fish in the food. We feed them. Sometimes they eat, sometimes they don't. The food will fall to the bottom, or the fish will eat it. No matter what, it is going to create ammonia through the metabolic process or through the degradation of the feed. So the ammonia in the system is actually toxic to the fish. So that's not a good thing. We need to get that out of there. And this is where the bacteria comes into play. So you have your biofilter, which converts that ammonia to nitrite. Nitrite is also toxic to fish. And so we have further bacteria that convert that nitrite to nitrate. Now, nitrate's not necessarily toxic to fish, especially in low amounts, but it could be detrimental to production, especially within the biofilter, if you get super high amounts or accumulation of it. So we usually have to do something about nitrates accumulating over time. And that's where the plants come in, because this essentially acts as fertilizer. The plants are able to easily utilize the nitrates. And so the biofilter creates the nitrates through the production of ammonia, and the plants take the nitrate out of the water because that's what they use to grow. All right, you may advance the slide. And that's pretty much it. I have some resources down here. These are just some of the things that I used to make this talk. I know that Katrina and Becky and Tiffany have a bunch of other stuff available for you guys. I just want to say you can reach out to me, or you can reach out to Laura, who I know now is on this. So there you go, Laura. But no, Laura's very great at aquaponics, and I'm much more of a recirculating aquaculture systems person. So please feel free to reach out to us to any questions, of course, at the end. So I'm done. Thank you.
Thank you so much, Eric. We appreciate it. And I think that was a great technical introduction to how aquaponics really works. So now we're going to get to see that in action at Island Coast High School in Lee County, Florida. So I'm going to go ahead and set up this video for us. We'll watch the video together. It's about 12 minutes long. It goes through a couple different systems that are there. And just a warning that some of the audio levels do kind of jump around a bit, so you might need to adjust as you're watching up or down. And I'll try to have the closed captioning on for you as well, so that you can be sure to hear and gather all the information. And then Joe will go into a presentation after we watch the video. So just give me 1 second, get that pulled up, and we'll get started.
Hi, I'm Joe Mallon of the Academy of Natural Resources here at Island Coast High School. This is our motto, science, sustainability, and stewardship. So we're here to talk about our hydroponic systems, our aquaponic systems, I'm sorry. And so let's do a little tour. Right through here is our aquatics lab. This is where some of the magic starts to happen. Come on now. So obviously this has been a COVID year. We shut most everything down because we don't have a whole lot of students. So what we've done in the last couple of weeks is just start to rebuild all of our aquaponic systems. So come down here. This is just a little aquaponic system that we have going here. We keep our tilapia in there. Over here, our kids love doing this one. They love cleaning this. This is our clarifier, and of course all the waste comes up over here, and then they can take the little hose, put it down here, vapor comes out. This is old school here, and then siphon it out all over the place, and we gotta take care of it. From there, it flows down this pipe down there, that 6-inch pipe down there. We have an air lift that you come down here, check it out, pretty cool. We use an air lift to push the water up, so we're not really using any pumps. Look in here, we have some pretty nice water flow going. We're going to start using this system. Probably we're not going to use any of our aquaponic systems until next year after this COVID year. Flows down there, comes through the NFT system. We used to have a deep water culture here, but we got rid of that. We're now supplying a lot of the vegetables for the school district, so we have to go germinating up pretty much full bore around here. We raise our fish over here. We no longer breed fish here. We found out that it's a lot easier to get the fingerlings. So you get the fingerlings, we start raising them out here. These are burial vaults. We bring the fingerlings in here. They start to grow up, then we bring them out to the aquaponic systems and the aquaculture facilities. Come on out. Okay, like I said, we shut everything down due to COVID, but over here is, about 6-8 years ago, I took the UVI long course at the University of the Virgin Islands for their aquaponic class, and so we kind of mimicked the one over here. As soon as I came back, I built one over there, where our NFT system is now, and it worked so well we decided to expand it. So this is where we're at right now. The kids are just getting ready to hook up the filtration. We got some water in the pools. they're cutting out the rafts. So basically what we do, they're divided into two parts. We have 4 800-gallon tanks. So we have a vortex filter in here. The solids will come, oh actually, yeah, that's pretty, isn't it? Anyway, the water comes up here, through here, into our vortex filter. All the solids come out of the vortex filter. Over here will be a mineralizer tank, and then it has an option of going into here. This is our biomedia. Can't really see it, it's too hard for me to pick up right now. Then we have an option to send it down to the rafts with the lettuce or whatever vegetables we decide to do. Goes up one side, down the other, into the sump, or directly back in. So it's kind of a hybrid system. It works pretty well because I've done this over the other side. We had some minor problems. We've had this big grand dream of putting my aeration in the bottom and making it all out of concrete, and guess what? It leaked like a sieve, so we just put liners in this year. So this system here will do about 400 heads of lettuce a week, if that's what we choose to use with it. Now the cool part about this system here, if you take a walk over here, collect our water. We have a 2,500 gallon cistern. If you look over there, we have a what is that, about a 5 kW solar system, 15 kW solar system. So everything we do here is totally sustainable, off-grid. We try to collect as much water as we can. It doesn't really work the whole time, but for the most part we can collect the water. So this is our one system. This is basically a modified deep water culture from the EBI system. Come on over here. Obviously you can see that the vessel right now is full.
So, to transplant into an NFT system, you take the seedling, these are lettuce, you rinse the roots, you put it into the net pot to plant it, and you add some hydrogen to the pot. And then the little pot has to come over to the NFT and sit with the roots down in the flowing water. So if you check underneath here, the water flows fast, and the water has nutrients that have come from the fish over in Aquaponics.
Hey, now we're coming up to our Aquaponics NFT system. This will be back online probably by Wednesday or Thursday. These are next to the pools over here. If you come down here, the kids just got done cleaning it out. They decided they had to do some modifications. So right now they're filling the pool up. So this should be going soon. So basically, if you look at the system, we'll probably keep it between 500, probably 500 fish in here. Okay, it goes through kind of just like the other one into the swirl filter, which is over there. They're cleaning the mineralizer tank, which is that square tank over there. They decided they wanted to come up with a new system instead of bird netting. So they're creating basically like a kind of using this large biomedia instead of the net film to grow the bacteria on.
So here at Island Coast, this is the tank that we used to grow our tilapia. The tilapia are swimming around in the vortex in order to build the mussel. The mussel is the part of the fish that we eat. The tilapia's droppings are collected and then filtered back through in order to put the water back into the tank.
So they're cleaning this up. Inside here will be a big mesh with biomaterial. This is where we get our anaerobic bacteria growing. Then it has a choice of going, if you look at the valving down here, which is kind of hard to see, we can either let it go. If we don't want to use the aquaponics, we just shut this valve off, open that one up, and it's just basically a RAS system, you know, a recirculating aquaculture system. But what we'll do is we'll open this valve up down here. Down here, this is the other one they decided to modify. What we found out last year was that if we brought it straight down and up, our system used to be a pipe coming straight up, out, and down the channels. But what would happen if we didn't harvest within 4 weeks, we'd end up getting a lot of the bio material from the filter getting caught on the roots, and it would just kind of get some root rot going. So this is what they just built. I'm kind of proud of them, actually. I like this system. What they just built is they took a 35-gallon drum, drilled a 2-inch hole in it. If you look at, and I just cracked it, that's not good. This pipe is going to come into here. There'll be a valve to valve it. And what's cool about this, you take this out, the water's going to come up from the bottom, and any kind of biomaterial will get caught in the filter, and it can be cleaned weekly. And then it'll come out here and feed down. And so I think we're going to take care of our root rot problem that we had last year. This system will do about 200 heads of lettuce a week. If that's what we choose to grow, it's totally up to the kids. They pretty much decide everything. So this is a quick overview of our 2 aquaponic systems.
And Joe Mallon, right over there, I can see that you've got a natural wetland as well. So what do you do with that?
Oh, we treat our wastewater over there. So basically we got all kinds of plants over there. So after, of course, you have your waste coming out of the swirl filter, so you have to treat it some way. So we basically just have a valve so it goes into that natural that wetland. Or we have another, like over on this side, if you see, we have this is just part of our aquaculture facility. They're putting a roof on it before they start the new filter. So we have the same thing going on over there. So we do use constructed wetlands to filter our wastewater.
Wow, so this is a really big system. And I heard that you have helped other schools to build smaller systems that are more sustainable for smaller programs.
For years we've been setting up schools with different types of aquaponic system, whether it's just a tabletop system where we got, basically get a cart, put the tank on the bottom and run the water onto a deep water culture, or an NFT system, or whatever they want to have. So we've been doing that for years. It's helped a lot of teachers that are interested. We've done a lot of middle schools. A lot of the middle schools, if they like the system, they'll either keep it and expand on it. If they don't like it, they bring it back to us and we rebuild it and take it to another school.
Yep, and we'll show a clip from Littleton Elementary, a system that's NFT that was built about 10 years ago.
Oh yeah, my kids went over and helped them. Yeah, it's been about 10 years?
Yep.
Holy crap, it's been a long time.
Pretty awesome.
We've been doing this for a bit. It's a great way for students to learn. It teaches, basically we're not really doing anything except for totally mimicking nature, and that's about all you can really do in the world.
Yep, applied science at its best.
Okay.
We're here at Littleton Elementary looking at the NFT system. They have a little bit different process here in methodology. They have their plants in a little bit of media and weed stock cloth, and then the roots grow right out through it and down into the water that's recirculating through from the fish. And as you can see, they're growing really well in the nice sunlight. So here's one of the pots. And that's what the water looks like down in there. And so with their system, the water is pumped from the fish pool and it goes up into the top, and it just goes all the way around and then back to the pool. And they've got a little 18-gallon tote with bio balls and filter media in the top that helps take out some of the solids. They also reuse trays from the cafeteria that are styrofoam and they float, and then they can germinate their plants in here. And the fish are hiding underneath the shade cloth in the water, and you can see the filters are keeping the water really clear.
Okay, cool. So that was a quick overview of what we got going on here. Let's see. Let's go with some questions. Let's see the PowerPoint first. So if you could slide on and see what my next key points are. Academy of Natural Resources. Okay, yeah. So our program here is a 4-year program. It can be a 1-year, can be a 2-year, can be 3-year, can be 4 years, depends on whatever they want. We always have to start off with agri-science because that's the foundation. Then we go to aquaculture 2, aquaculture 3 and 4. And we're all electives. So yeah, the kids, if you choose to be here, they kind of front load us in the beginning to get a lot of students in here because, the workload, it is a science class. So they they have a tendency, some students have a tendency not to like to do the schoolwork, but it's kind of school, it's kind of it's intensive. They got to do a lot of work. So, but not only do they do do they do book work, the hands-on work obviously is fairly intense here. Let's see, next slide. Okay, so yeah, so the students, this is really is a student-run program. They decide what we do each year. I don't know if you noticed like the greenhouses, everything you saw out there, the students that they'll have built. They laid all the block, they ran all the pipes, they did all the plumbing, they designed everything. So this is a very, it's kind of like a shop class for geeks. So the kids are very active in taking care of this place. I couldn't possibly take care of it myself. So they do everything from water testing to the figuring out what kind of system they want to do to treat the waste. They've done things from like screening the waste and putting it into a 250 gallon tote and then selling it to people for their lawns, or we've even used it on grasses, on the fields for a while and tried things like that. They take control of the pests. We try to do nothing but biological pest control. They germinate everything. They transplant, they harvest, they process, especially for the tilapia harvest days. That's an all-day event. So they get to do the whole phases of agri-science and aquaculture all put together in one. And they even get involved with the transportation and storage. Like once we harvest, it's all got to be weighed out, and it's got to be butterflied and weighed, and then we vacuum seal it so that it's ready for sale. Let's see, what students also plan to innovate systems. Yeah, so everything here the kids more or less design. Next year they're designing a polyculture with a cage system, so that we're going to be raising catfish and tilapia, and at the same time running it across a hydroponic system, which is actually going to use to feed red claw. Okay, I guess we can do the next slide. What is my next key? Fishy business starts in the lab. Yeah, so we did a quick thing through the lab. Everything in the lab is a smaller system of what we have outside. We're not only in aquaponics. Year ones, when they do the agriculture, it's pretty much all hydroponics. We have a large three greenhouses out front where it's totally off grid, run on solar, collect rainwater. We have, oh my goodness, I don't even know how many systems we got, how many things we got going on out there. But we can fit easily in that system out there. We can feed our school and other schools with the vegetables, but that's pure hydroponics. So we'd like to show everything that we do hydroponically. Then we have add the aquaculture, and then of course as time goes by, they incorporate the aquaculture and to the aquaponics, the aquaculture and hydroponics for the aquaponics, and they have systems totally devoted for that also. But it all starts here in the lab. They have to learn everything in year one, how to do the basic maintenance, how to check the pH, make sure, for aquaponics, you got to try to keep the pH at 7, because, the plants like a pH of 6.5, and the tilapia kind of like the 8, so you kind of keep the happy medium with 7, so you have to check that every day. There's feeding regimens, they learn how to germinate in here, how to raise the fish, and then everything that is seen here in the lab, we have much larger systems out throughout the school. Next slide. Okay, more in the lab. Okay. So, he was talking about a degasser. See the picture on the right-hand side? That is a degasser. That is exactly what he's talking about. We used to breed the fish here. But the problem with breeding fish here, to be completely honest, is half of them are female. Nothing against you females, but the reality is, females, when they're mixed with males, they start breeding, and then they put all their energy into that. They don't grow as fast, and to be completely honest, we got to kill them. So we had to think about what to do with them. We at one point we thought about, let's use it for bait fish, and we found out that wasn't cool. It wasn't cool at all. So we didn't do that, and so we ended up having to kill them. So it really turned out to be much more efficient just to get the fingerlings. So that's pretty much what goes on here in the lab. Right there, that is our fish grow out. Let's see, what are kids doing here? They're doing they're doing colorimetric pH readings. We usually buy the pH pens, but lately I've been noticing that they're not holding up very well. So we're going back to the old school and just doing colorimetric measuring of the pH. And kids kind of like it there. So they got to do the pH on every pool every day, and then we adjust the pH accordingly. Okay, how do we manage students in the classroom? Holy mackerel, that is a really, really good question. especially in this hybrid year, because, you know, we got to do COVID year, we got to do a hybrid teaching, so that's kind of fun. But teams of students choose what task. We have a task board, and then once the lesson is over, they'll just choose their task and go to the task, and then basically what they'll do is they'll tell what they did, and then I have upperclassmen. They get the cards, they look at it, find out who did it, and they get graded accordingly. Those tools are all set up. They need to be cleaned when they're done. One group will notice what the jobs are, put it on the board, and once the board job is done, they cross it off. They got to keep notebooks all over the place and try to communicate, because like some things, multiple classes have got to be working on. Just one class can't do it because they might only have 40 minutes to an hour and 40 minutes to work on, and that's not enough to accomplish anything. So they have to communicate with one another, and they either do it through the boards, or they're pretty good at their little chat groups too, which I'm not really involved in any of that. But they work really, really well together when they're trying to accomplish something. And, you know, when they're trying to accomplish something, things are really well. But trying to force them to do things, you know, it can be difficult to get them all onto one page. Let's see what the next slide is. Let's see, what do we got here? Okay, so how do we manage? Okay, here, how do we manage breaks? That is probably the hardest thing about doing this. Breaks are hard. You know, somebody has to be here every day. You know, I think I've been doing this here for this school for 13 years, and I bet I haven't been out of here for more than, you know, maybe 300 days the whole time, which sounds like a lot, but it really isn't. So basically, you got to incorporate students to help, friends like Susie who knows what's going on. I have other teachers that like to get involved, and then it kind of ebb and flows. You know, teachers will come in, they'll get really involved, and then they'll move on to another school. So you got people coming and going. So you really kind of have to have an in-network support system. It's not something you can do on your own. So you know, other teachers come in, we have volunteers, parent volunteers. People usually like what's going on here, so they want to kind of get involved. So teachers within the school actually come. We last summer we were doing what basically right when COVID started hitting, we were having food lines, so we kept the food running. Usually I shut the place down for production during the summer. We kept it going. The school district got behind us and, you know, let us come and get it, pack up the food, take the food to where it needs to be, and things like that. That's the other thing for summers. Summers are brutal, man. Summers are absolutely brutal. I can't tell you how many times during the summer, even with me being here, something would go horribly wrong, and I'd only come in once a day, and you have a massive fish kill. Summers are brutal. So things you can do is like get automatic feeders and have people check in all the time. Usually, and no, not usually, always, the custodial staff are into it, and they keep a pretty good eye on the place. And if anything goes wrong, they will give me a shout. But like I said, you gotta have a support system for something like this. It really, you know, I'm pretty much a one-man show here at the school, but luckily I have a large enough support system outside of the school that we can continue to rock and roll here. Is there another slide?
I think that's the end of your presentation, Joe. Thank you so
much. There's a lot going on here. If you have any questions, feel free to, I'll put my information out there. I'm not really quick at getting back with email, to be completely honest, but if you send me something, I will get back to you. I guess that's it.
Great, thanks, Joe, and you'll stick around for. Yeah, and Joe will stick around to answer questions. I'm sure many of you have questions, as I do. But that's an amazing program, and it was cool to see it in action. And so now we're going to hand it over to Katrina Bayless with the Florida Department of Agriculture and Consumer Services, Division of Aquaculture, and she's going to share more about mini aquaponics systems and other resources.
Hey, hi everyone. As Tiffany said, my name is Katrina. Just to give a little overview of what I'm going to be talking about, it's going to be quick. So I know there's probably going to be questions because I'm going to be running through this stuff, but feel free to put them in the chat and ask at the end as well. So we're going to be talking about the mini systems. The guys talked about these massive systems. I guess this should be more called a micro system, especially compared to the other stuff. We're going to talk about some materials that we have, tips and tricks that I've learned over the last 1.5 years of running these systems. Our resource roundup at FDACS, why you should teach aquaculture, our education resource page, our new commodities poster from FDACS, upcoming teacher training workshop, and then the links will be at the end. So next slide. So the mini aquaponic systems, let me adjust my camera here. So these are the mini aquaponic systems. Just a little background on why we started with these systems would be that in collaboration with FAITC, we got a grant to go to the FAST workshop in 2019 and give away a bunch of these systems to some teachers. And with some materials and resources, activities, some lesson plans and stuff like that. Unfortunately, COVID happened. So 2020 wasn't exactly the most productive year, but with my experience with the systems, as well as a few really dedicated teachers, we were able to get some pretty good data. So let's set this up.
Sorry about that. Yeah. Also, people can go ahead and just toggle left and right with the gallery view, and then you'll be able to see Katrina figure.
Yep. So if everyone can just make me big, I'm not going to be talking about the slide anymore. I'm going to be doing a little demonstration. So this is our mini or micro aquaponic system. So like Eric was saying with the big systems, it's basically the same thing. You've got your grow bed, you've got your tank where your fish goes, and it's all connected. The water just completely flows through. So this is a back to the roots aquaponics system. We got these just because they're really simple. There's a really easy setup. There's nothing special to need. Most of the materials you need come with the kit. There are other ones that you can get. This was just easiest for us. So what you get is a grow bed that sits on top, and these individual grow beds that have grow stones in them. So they were saying they use hydrogen for theirs. We actually provided hydrogen for our teachers because the kits that we got didn't use hydrogen, it used these grow stones. The updated version of Back to the Roots systems actually use hydrogen and not these grow stones. We learned that when we were looking for the next round of grants, which I prefer the hydrogen. These grow stones are really porous and roots get in there and they are a pain to clean. So I actually prefer the hydrogen over these. The new system does not come with rocks, but the old one did. When you get it, I suggest putting rocks in it. But this system, here, let me take this off, has a little filter sponge. This is all the filter that comes in this system. So there's not a lot of, the solids will settle out here. Hopefully they don't go back down in the tank. There is a little maintenance needed with cleaning the rocks and stuff like that, but we'll talk about that in a little bit. You also get this tank. You'll notice it's not very big. We'll talk about that in a little bit, why it matters to notice that. A little tiny pump. And this is the spout that puts the water from the tank into the grow bed. Okay, so if you set everything up just like this, a tip we noticed, if you get this system, when you set it up, make sure that the this plastic piece right here is pulled relatively tight, because if this isn't sitting tightly down, it will make lots and lots of noise and annoy the crap out of you. It's really annoying. And then your grow bed goes on top, just like this. There's a hole right here where that pump shoots out into this grow bed. Then your things go on top like this. And if you set it all up, put your water in here and your fish will cycle just like this one behind me. And do some TV magic, just like this one back here. So if I bring you a little closer, we'll look at this one. So I've got zebrafish in my tank. Like I said a little bit ago, you'll notice the tank is very small, okay? So this is really gonna limit the amount of fish you can put in. Even if you don't get this system, you get another small system. We recommend that, one, if you get a betta fish, you can't put another betta fish in it. So you get one betta fish. Two, goldfish are gross in that they release a lot of waste into the water. And even though you see this, goldfish go in bowls and stuff like that, it is actually recommended that goldfish live in 10-gallon plus tanks. So this is not a goldfish tank. What I have in this tank right here are zebrafish, and they've been living in there for almost 2 years now, doing pretty well. Up on top, Tiffany asked me to talk about this. These systems come with microgreens, and unfortunately, fortunately and unfortunately, microgreens will grow just in water, just on the seeds themselves. They don't necessarily need the fish. However, if you're constantly cycling through on your different grow beds, greens that are growing, so you have mature greens in there or microgreens in there at all times, it will filter the water enough, just like Eric talked about with your nitrogen cycle. So these, so you're not having nitrate buildup because you have mature plants in the top at all times. I'm currently growing aloe right here, and then a little spider plant, just because I got sick of constantly replanting microgreens. And I actually ran out of the stuff that came. So I just grabbed some plants from my yard and threw them in there, and they're doing great. What else? What else do we need to talk about? Hang on, let me look at my list because we have all of our tips and tricks on here that I needed to discuss. How to clean the pump. That was another one that was requested. So a little thing that's not mentioned in the instructions for this, the pump, at some point, a lot of these, it'll stop running as full as it normally does. You'll notice that. And again, it's not on the instructions, but a lot of them will have like a screen on the bottom, and you can just pop it off, whoops, just like that, and clean off the fan that's down here. It's probably clogged. Put your pieces back in and snap it back on. Oops, other way. And snap it back on. And then it should run much better. So the first system I had, so I have two systems. The first system I had set up, the pump stopped working and I thought the pump broke, and it was literally just as easy as cleaning out that little fan. Feeding your fish. Don't overfeed your fish. 3 times, 4 times a week is plenty, especially for these guys. If your system, like this guy right here, starts to get really algae filled and really nasty, you're probably overfeeding your fish. Something else we noticed is that teachers weren't giving their systems enough time to cycle when they first started up. So give your like Eric said, your bacteria culture is very important. Give it time to grow before you introduce fish into the system. If you don't, your fish are probably gonna die, and then you're gonna have to start over. Jungle makes tablets that are like a quick start. They work pretty well, but you still need to give it time. We suggest that if you do that quick start, or if you add ammonia or something like that to the system to get your bacteria culture started, that you use some sort of test kit in order to make sure the water is okay before you add your fish. Again, don't overcrowd. Decorations are encouraged. It's a small tank, but you can still put some decorations in there. We at the office, as well as some teachers, that have noticed that there are issues with pH. So before you set your tank up and when you do water changes, make sure you check the pH of your water, because that's probably what's going to kill your fish if you have a huge pH problem. So these are actually pH correction tablets that you can get as well, but just make sure you know the pH of your water, because a lot of people don't. And Tiffany also wanted me to mention, so we gave these test kits away with our systems when we did it. It's important to have this, don't go in blind, but follow the instructions. Everything's written on the bottles, but when you use them, it is really important, something that's not written on, I think it might be actually, is hold them straight up and down when you're using them. And that's so that all of the droplets that go into the vial are the same size, and it keeps it the most accurate. This is a cheap test kit. It's not super accurate, but it is accurate enough for these systems. So that is our quick system demo. And then we will, running over time, run through the other stuff really quickly. So hang on, I got to make myself smaller again. So the first thing we want to mention, just on the grants and teaching materials information side of thing, is we started at the beginning of COVID, when everybody went virtual, we started this newsletter called the Resource Roundup. It was weekly and it has turned into a monthly thing now. And there are well over 150 resources that we posted. We try and put a lot of grant opportunities and job opportunities and funding opportunities and stuff like that on there. So if FDACs, if Sea Grant or stuff like that are posting things, it's probably going to be on this. So if you would like to be added to this mailing list, please let me know. Just send me an email. Or you can visit the archive page and see what we put and also sign up through there. And next slide. So just a quick why aquaculture. I have an entire hour-long presentation on why you should teach aquaculture in your schools. We know that aquaculture is a growing industry. It's rapidly growing. There's not the workforce behind it that is desperately needed. But there's not this like, there's not a lot of curriculum. There's not a lot of materials. There's not a lot of standardized things that we can put into our classrooms, especially in the younger ages. We have teachers that are really dedicated, luckily, that have come up with these curricula basically by themselves, and it's very piecemeal. So we're trying a little bit to get this more consolidated. Next slide. So again, why? And I think the previous speakers hit on this really well. Aquaculture covers a lot of things. I've done conferences with ag teachers and they talk about how their students go home and have blueberries and have to pick blueberries, or they have to like farm and their gardens and stuff like that at home. The last thing they want to do is come and do it in school as well. So introducing aquaculture programs not only fulfills a lot of these sunshine standards, but gives these students something fun and exciting and education that they can learn in order to get them involved in these, these like in agriculture. Go on the next slide. So just to touch base on our system. So again, this is not nearly as huge as the systems that you've seen previously, but this is just our small teaching system at the Holland building. We did a rebuild on this system right before we left the office for COVID, when COVID hit, and we just installed this windowed tank so that when we have students that come that are too short, they don't have to look over, they can just look in the side of the tank, which is a pretty nice addition to the system. And we also have, that's our tomatoes in the middle. I was super proud of those tomatoes. And then right when I was about to pick them the week, probably 2 days before, someone came into our garden and took all of them, and I was really sad about it. But we got a lot of tomatoes. We also got a lot of peppers out of that system. Next slide. So we were hoping to kind of take you guys through this page live, but unfortunately I went over on my demo a little bit. But our resource page is kind of our one-stop shop for everything. We try and put as much stuff on this page as possible that we want to share. If you look at the very top of the page to the right-hand side, there's our standards link that takes you, through the standards that are covered through aquaculture programs and our success stories. On that note, if you would like to be added to our success stories because that page is looking a little dated, please let me know so we can get you up there. There are the helpful contacts and fact sheets that, seriously, that you guys saw. Stop. That you guys that have already been talked about earlier. So with our business resources, our field trip opportunities and stuff like that. We have some funding resources on the page, but like I said, most of that is going to come from our resource roundup. We also have our technical assistance contacts. Eric Cassiano is one of our technical assistance contacts, and lots of other people. Stop! This is seriously has been quiet this whole time. And we also, our aquaculture education share page is also on there. That is a Shutterfly page that we don't use as much anymore. And on that note, we are really trying to put together a consolidated map that is clickable. It's nice, really easy to see. That gives you an idea of the technical assistance, whether that be an IFAS agent, an FX agent, or a farm near you. And hopefully we can get that on our webpage soon. We don't really use that share page very much anymore, but if you would like to be added to that share page, please let me know. And when we finalize that kind of move over of everything, you'll be on that list. There are also PowerPoint presentations on the on that page. They're currently being updated. Some of them, the data is a little dated on them, but we're working on getting them updated, and also automatic. So someone's giving the lecture instead of you just getting a PowerPoint presentation and having to give the lecture. There are links to the IFAS resource guides, and at the bottom is the other resources with that roundup. And I would strongly suggest signing up for the roundup list and emailing me directly for that. Okay, next slide. This is our aquaculture commodity poster that FDACS just put together. This took a while to go through because we went through, all of our inspectors and everything to try and get a good overview of aquaculture in Florida. This does not include every single farm. This does not include every single commodity, but it is a nice broad overview of aquaculture in Florida. There's some information about aquaculture types, as in, our baskets, our ponds, our tanks. And we are working on getting it virtual right now. I'm putting it on our website. It's huge and there's some ADA concerns, so we're trying to get that done. And if we can go to conferences this year, we will definitely be handing these out, and I am sure they will go quickly. Next slide. And last, to kind of touch base on our aquaculture teacher training workshop in July, we are currently reviewing applications that we had posted, or we had posted this, and we're currently reviewing applications for our RAS systems. We will be very likely sending out a second call for workshop attendees only. So you won't be getting systems. There's more details on this on the announcement, but you won't be getting systems, but there is training that goes with it. If you can't come in person, it will be virtual, and the workshop is free. So if you feel like you didn't get enough out of this and you'd like to join us for another workshop, please be on the lookout for that announcement. If you would like to be on the list if we very likely send out that second announcement, please email me or Marcy Cockrell, which her information will be on here as well, and let us know. Next slide. And there's the links and my contact information. Thank you so much.
So I just want to do a quick wrap up of our resources, of what we have gone over today. So the difference really between aquaculture and aquaponics, I hope you all understand that now. Cultivation of fish and other aquatic species in water is aquaculture. Aquaponics is the combined cultivation of aquatic plants and animals in a recirculating aquaculture system. I think it was really cool that we did this workshop on the follow-up right after hydroponics to really see how they all work together and build on one another. Large recirculating aquaponic systems can require a lot of maintenance, as we've seen. So if you have an entire program like the academy that Joe has, there are opportunities to continue to involve students in that maintenance. But if you don't have a program and you still want to get involved in aquaponics, you might want to look for something that is more of a single fish or a few fish unit, like the mini aquaponics that Katrina just went over. And just a note that some of those units will be available at a workshop in the fall, and that will be hosted by Florida Agriculture in the classroom as well as FDACS. So follow up with us in the fall if you would like your own unit for free. And there are many connections, as we've seen, to Florida teaching standards, more curricula being developed right now and more to be rolled out. And aquaculture really offers students the opportunity to do science rather than just learn science like we've seen. It's really a hands-on opportunity for building those technical skills that could carry into their career. So There's really no reason not to do it, and you can scale it appropriately. And as we've seen, there are a network of people that are here to support you in Florida around your aquaculture and aquaponics journey. So please reach out either through the Facebook group with the School Garden Leadership Training Series or to any of the resources that Katrina mentioned as well, and join the network. And so with that, we are gonna roll into our optional Q&A session. And if you have already put any questions into the chat box, we'll cover those, and you can keep more coming. And Becky will facilitate this portion of the presentation. So just a reminder too, before we jump into that, to please complete the surveys before you leave if you do have to leave early. We have both our 5-minute, just a quick feedback on the session, how it went, and then if you would like professional development, you can fill out that survey as well. Thank you.
Okay, so the first question came up during Joe's presentation, and the question was, what do you do with the product from that system? Susie answered, veggies are used in the school and excess taken to other schools. Fish are filtered and sold to help support the program. Joe, did you want to expand on that, or does that cover that?
That pretty much
question?
covers it all. We usually send an email out to the district depending on the harvest, the size of the harvest, and you know, send an email out, it goes pretty quickly. We sold out. We just harvested like a week and a half ago. We sold out in a week.
And how much do the fingerlings cost, and how many do you get, and how often do you have to purchase them?
So for me, I had a friend that worked that owned Aqua Saffron. He sold it, so I haven't really touched base with the new owners yet. But with the deal I had with Jim at the time, I would just give it $500, and he would give me as much as I wanted to. I don't have that contact is no longer. I will be making contact again, and if anybody wants to know where I'm going to get them, I'll let you know. I'm working on that one now.
So I had a question, and this was not in the chat box, but that was a lot of equipment. How did you even start, and how did you pay for all of that?
Okay, originally when we came up with this design, the school district was pretty cool, and they gave us initial $60,000 to fund it. But then we just started fundraising, selling everything, doing all kinds of things, and we just managed to build it up. And then one of the best things that I've discovered recently, which I wish I would have known a long time ago, is that if you can give certifications for this class and for the ag class, and then you get certifications, and for every kid you get certified, you get a certain amount of money. And I know I got to be completely honest. I don't try to sell anything for profit anymore. I give a lot of it away, and because I make enough money on my certifications to finance the place. But I did get a grant from where did I get? I got a large grant from. I totally forgot who it was from. I should know, but I got 180. It was supposed to be a $500,000 grant, but they last minute they had an emergency, and I got 180,000. That's where I got the money to build the large part of it. So basically, what I did instead of paying people to do it, I had the kids build everything. The grant was from West Coast Inland Navigation. Awesome people, and they helped like 6 years ago with 170 or 180,000. I don't even know what exactly it was, but they were pretty cool, and they helped like build the different. Gave me the funding to purchase a lot of the equipment.
Awesome. So this is going to be a multiple part question because I think they kind of all go together. It says, how often, because I know you said you didn't sell, how often and when are the fish sold to be eaten? Are the fillets sold to staff and parents?
So it depends. Like, again, remember I told you this is kid run. In the beginning, kids really, I had a group of kids that just liked the fillet. So we would design a program to harvest every month, where we do 500 fish or so every month. Right now, we're not really, I don't have that many kids that like the fillet, to be completely honest. So I went from going from like 10,000 fish to, I think I'm keeping about 2,000, 3,000 fish on hand. That's why I'm not putting very many in the pools out there. So it's kid based, but yeah, we this year I'm going to harvest 4 times with probably about 400 fish each. And then we like I said, I like to teach them the whole process, from growing, we don't breed anymore, but once you start growing them out, and then you processing is a big part of it, and then sales. I mean, I like to teach the whole thing. So the kids coming up are now talking about wanting to do more. So I don't know, but no matter what we do, I got to make sure I have the kids to do it, because it really, like I said, I can believe it or not, I've been doing this for 13 years and I can't fillet a fish.
So something came into my head while you were answering that question. With that many fish and that big and harvesting and selling, do you have to have any permitting, certification, inspection, any of that kind of stuff?
Yeah, we get inspected twice a year from Florida Division of Aquaculture. They come by, inspect the place, have a chat.
Okay. And Susie answered is it called CAPE funding? They get funding from certifications through that. The next question Eric actually answered, but I'm going to read it out just in case anybody. Would it be possible or make sense to sell the fish at the end of the school year and then let the system rest over the summer? Eric said he actually suggests doing just that. It gives you time over the summer to not be there. Also, there is a lag time once you start the system in which the bacteria needs to grow before you add fish or animals, which is a great way to teach about nitrification. And then my last question, Katrina, somebody asked this question when you were presenting, are you part of the scientist in the classroom group?
I am not, but I have been meaning to do that. So not as of yet. FTAX does some visits. Again, before COVID, we were doing school visits. We had schools come to the Holland building for visits and stuff like that. But we have been meaning to expand that a little further. So I'm not yet, but I'm working on it.
My next question is for Katrina and Joe. Is there an intermediate size system you would recommend? Something in between the large system Joe showed us and the small tank Katrina showed us.
Oh, absolutely. You can use it. You can go do like a 90-gallon tank and just expand, depending upon what your fish is, you do the coordination with the amount of food that you put in. It tells you how much of a grow bed you need. Like the one that Littleton has, that's a nice little system. They work really well and they're easy to maintain.
I'll also touch on that a little bit. So for schools that have garden programs, there is something called a decoupled aquaponics system. So that means there's still the fish and the plants involved. It's just there isn't a direct tank or a direct line taking the water to those plants. It's just a fancy way to say when you do a tank clean, say if you have a fish tank in your front office or something like that, the nutrients are still just as great for plants. So if you have a garden, when you do your water clean, go ahead and take the water and put it on your garden and use it to grow those plants, and you can still teach why that water from your fish tank is helping out your plants.
I had a question that somebody gave just to me that asked about the field trip and how they sign up. We are still working through all of that. There will be an email out and an announcement on Facebook once the registration goes live. The webinar access to that workshop or that field trip will be limited to 100 classrooms, but on top of that, we will have live streaming on our Facebook page. And so somebody will be monitoring that for questions as well. So that is all the questions that I have seen, but feel free to unmute and turn your video on and ask questions.
Can I also add something about the certification? So I know that Joe had said that their school is certified. FTAX does not require certification for schools, but it's super helpful for us. One, it lets us kind of keep track of everybody and who would be able to help other schools. And it also gives you guys, I mean, like Joe said, you're inspected twice a year because you have the certification from FTAX. So if you want one of our inspectors to kind of give a talk about aquaculture or something like that, that is also on the table. They can't do it every time they come, but if you give them some leeway, it might be another learning opportunity for your students.
A question just came in. What kind of certification / license did you need to process and sell the fish?
We went through the schools. You know, the cafeteria has whatever licenses they need, and we go under their license.
Do any of the other presenters know of any other forms, certifications, any kind of paperwork that should be done before somebody starts a system, possibly as large as Joe is?
Just a note to just make sure to check with whoever your, you know, if you're with a school, check with your school board, check with your principal. Just different municipalities might just have some different food safety stuff you want to check with first.
Yeah, and Susie put that in the chat as well. The Island Coast works very closely with the Food and Nutrition Services Department. So yeah, if that's something you're thinking of, making sure that you check all the boxes in relation to food safety and serving food with the FNS department.
All right. Well, feel free to contact and follow up with each of our presenters. I want to give them a special thank you for being here today. We really appreciate having you and sharing all of your expertise with us. Before you leave, if you could, again, make sure to fill out our quick survey, tell us what you would like to see going forward, how we did today, we appreciate it. We also have our professional development survey if you need those credits. Stay in touch via our Facebook group, and then we will have our resources, slides, and video recording available in the shared Google Drive folder, especially a lot of the things that Katrina didn't get to go through in detail. I'll make sure to upload those there so that you have a copy, but be sure to check out that resource page as well. So with that, we are really happy that you were here, and we hope you join us on April 6th. So that's actually next week. From 3:30 to 4:30, we will have another great webinar. This one's titled Hi Ho, Off to Work We Go. And we're gonna have a panel of people who work in different careers in the agriculture industry in Florida, sharing with you about how you can communicate to your students about different agricultural career opportunities for them. So thank you for being here. We appreciate it. And everyone have a great day.